Hello all and welcome back to our sessions on finite automata. Till now we have seen in this section how to convert a given regular expression into NFA, how to convert that NFA into DFA, and then later on how to convert it into minimized DFA. In the previous session we had seen how to convert a NFA with epsilon to NFA without epsilon. In today's session we will be starting with converting a given NFA without epsilon to minimized DFA. If you all remember, we had explained, or I had given one note or a tip that whenever we have to convert NFA to DFA, the method will always remain the same, that is irrespective of whether the NFA is with epsilon or without epsilon. So we have already seen the guidelines of converting a NFA into DFA. So here, even if we have this NFA without epsilon, we will be converting it in the same manner how we did of converting the NFA with epsilon to minimized DFA. So this is the question wherein you are just simply given a tuple of M, okay, that is the DFA, NFA M is equal to PQRS, this is capital Q, this is our 0 and 1 are our input alphabets. The transition function is given below. The P is nothing but our start state, that is Q0's value, and S is our final state, that is F. Okay, so here we have the transition table. Using this transition table, you will first have to draw the transition diagram, only then we can convert our NFA to DFA. So the transition diagram will be as follows, that is PQRS will be our 4 states, out of which S is a final state as mentioned in the question, and finally we will all connect its states using this state transition table. Now let us check how we will be converting our NFA without epsilon to DFA. So here, as we can see, there are no epsilon transitions. If you remember, the rule of calculating epsilon closure for any state is the state itself first, okay, and then later on the epsilon transitions that are present in the state transition diagram. Since there are no epsilon present, we will have the epsilon closures for all the states as the states itself. So here for P, it will be the state itself. Then using this P, we will find the transitions over 0 and 1 respectively. So we will have a table consisting of A, B, C, D, E, F, G and H. Yes, there will be A to H states. Don't worry guys, and with this we will also be minimizing it into minimized DFA. So here we will, even though we have A to H states, out of this first let us mark all the final states. We will have E, F, G and H as our final states. Now A to B and A, then we have C and D, next will be E and D, next F and A, next will be E and G as a transition, E to G, F to E and G, G to F and H, and finally H to F and H. Now let us see the state transition table. How will it look finally after it is being converted from NFA to DFA? So this is what it will look like. We have 4 final states, E, F, G, H, okay, and here we can observe that there are no same transitions appearing in A to D, but there are similar transitions appearing in E and F and G and H. Since both are final states, we can rename them, merge them and rename them as X and Y respectively. So our next transition table will look like this, where we have A, B, C, D and X and Y, where X and Y both are final state. Now we are not supposed to stop here. If there are other states which can be merged again, try to find them and merge them again. So here we can clearly observe that we have X and Y again that can be merged. So we will merge them and rename it as Z, which will again be our final state. So here we will be left with this transition diagram where we will be having 5 states, A, B, C, D and Z. Z will be our final state, and the state transition diagram will be having Z as our final state, and A, B, C, D will be our states. So from A to B, okay, and A to A, that is the self loop, then from B to C and B to D, from C to Z, C to D, from D to A and D to Z, from Z it will be a self loop. This Z is acting like a trap state. In case you do not remember what a dead state or a trap state is, you can revisit the sessions which we have already seen previously. Now let us go on to our next topic, that is converting our transition diagrams to regular expressions. So here there are total 2 steps. Step number 1, write the state equations by looking at the incoming transitions. Now what do we mean by this? Suppose there is going to be a state transition diagram with Q0 and Q1 as our example. Q0 is our start state, and there are the incoming transition in Q0 is from Q1 over some input alphabet. So we will be writing the Q0's equation as Q0 dot 1, okay, sorry, Q1 dot 1, right. So whenever we will be having any such transitions, so we will write whatever, from whichever state it is coming to that particular state, the state number of that state and the incoming input alphabet. Also we have to add a epsilon to the start states equation. Okay, so we will see an example and understand the steps how they are going to be followed. Step number 2 is for performing any combination of the followings. So what are the following combinations that we can perform? The first one is substitution, second one is rearrangement, that is R, and third is applying Arden's theorem. Now let us understand what do we mean by Arden's theorem. The definition of Arden's theorem says that let P and Q be any 2 expressions, and if P is epsilon free, then the following equation in R, that is R is equal to Q plus RP, if it is in this format, then it will have a unique solution called as or given by R is equal to QP star. Okay, so we will, if we have 2 expressions, regular expressions of P and Q, okay, so when we write R, if it is in the format Q plus RP, then we can rewrite using the Arden's theorem R is equal to QP star. Now let us solve one example and understand how do we manage or find the regular expressions from the given transition diagram. So here we can observe that we have 2 states, Q0 and Q1, out of which Q0 is our start state. So step number 1 says write down the equations for all the states. So we have 2 states, Q0 and Q1. We have incoming transitions of Q0 and Q1 coming into Q0. So we will write Q0 is coming over A and Q1 is also coming over A, and since Q0 is our start state, we will add the epsilon in our equation. Now Q1 is having only one incoming transition over B from Q0, so we will write Q1 is equal to Q0B. Now let us see step number 2. In step number 2, we will take Q0 equation, as we can substitute Q1 dot A with Q1's equation. So we will substitute it. Now while substituting, just remember that we are substituting Q1. Okay, we are still having A left in the equation. So when we will substitute Q0, we will write it as Q0 dot B, and we will attach this A at the end, not at the beginning. Okay, we will attach it at the end as it is seen in the equation. So we will have Q0 is equal to Q0 dot A plus Q0 dot B A plus epsilon. So we have performed the step of substitution. Next, now we can rearrange our equation such that we can get it in the form of R is equal to Q plus RP. So this is R and this is our entire P. So now applying Arden's theorem, we will have Q0 as epsilon dot A plus BA star, because we can rewrite our equation as R is equal to QP star. So since we had our equation rearranged as R is equal to Q plus RP, we can rewrite the equation of Q0 in terms of R is equal to QP star. So here this is our R, this is our Q, and this is our P star. Next, Q0 will become A plus BA star, since anything applied with epsilon will be itself. Then we will rewrite the equation of Q1 by substituting Q0 in it. Again, do not forget this B. So here after substituting Q0 in Q1's equation, we will attach the B which was already present in Q1's equation. Now we have, whenever we will be converting our converting our transition diagrams into regular expression, we have to always remember to get our final state equations in terms of complete input alphabets. Okay. So here, since we got our final state which was Q1 in terms of complete input alphabets, there are no more state numbers present in our equation. We can write that our regular expression for the given transition diagram was A plus BA star dot B. Let us take another example to understand this much more better. Here there are 3 states with Q0, Q1, Q2 having Q0 as our start state and Q2 as our final state, having the transitions from Q1 to Q0 over 1 and Q2 to Q1 over 0, and from Q0 having self loop over 0 to over 1 to Q1, and from Q1 to Q2 over 1. Now let us begin with our step number 1, writing the equations for each state. So here we have 3 equations for 3 states. Q0 is having Q0 dot 0, Q1 dot 1, and since this is a start state, we will be adding epsilon. Again we will write Q1 as Q0 dot 1 and Q2 dot 0. Finally Q2's equation will be Q1 dot 1. Now step number 2, we will take Q1's equation as it is having much more potential to get it in terms of Arden's theorem, that is R is equal to Q plus RP format. To rewrite it, R is equal to QP star. Okay. So here we can see that Q2 is being substituted with Q1. Okay. Do not forget this 0 that was present already, and Q1 dot 1 from Q2's equation. Now we will by Arden's theorem we will rearrange it and make it as Q0 dot 1 dot 10 star. Now since this was this is R, this is Q plus R and P. Okay. So we have 1 dot 10 star. So we are left with Q0 1. Okay. So our Q was Q0 1 and P is 10 star. Now we will take the equation of Q0. As we can see that we have to get Q2 equation in terms of only input alphabet, since that is our final state. So now we will substitute Q1's value in Q0 since we got it in terms of Q0. So after getting it in terms of Q0, we will rearrange it and get it in terms of Q plus RP format. Then we will apply Arden's theorem and get our equation solved and in only input alphabets format. So we are left with 0 plus 1 dot 10 star dot 1 the whole star. Okay. Now let us find the Q1's equation, which will be again only present in terms of input alphabets, as we will be substituting it in this equation and rather than this. So here we are left with 0 plus 1 10 star dot 1 star dot 1 dot 10 star. So we have this Q0 in terms of Q1. So we will put this entire equation in Q2. We got Q1, the entire equation in terms of input alphabets. So we will substitute this value in Q2's equation because that is our final state. So here we will have our regular expression finally as 0 plus 1 10 star dot 1 the whole star dot 1 dot 10 star dot 1. Yes, these regular expressions are going to be somewhat this complicated, even if the transition diagram seems to be very simple. Now we will go to the final question for our today's session, and we will wind up the session with this particular example. So here we have 2 final states, as we can observe, Q2 and Q1. So we have to get both these state equations in terms of only input alphabets. So let's start with step number 1. We have 4 states Q0, Q1, Q2, Q3. So we will write down all the four equations from Q0 to Q1. Do not forget to add this epsilon in the start state. It will be applicable for all the regular expression that we will be converting from transition diagrams. Okay. So as we can see that Q1 and Q2 are the only two equations that we need to get it converted in terms of only input alphabets. Even if you will get scared looking at this particular equation, but we will have nothing to do with this equation as we will see the solution. So step number 2 is we will substitute Q0 in terms of using Q1 and Q2 equations, as both of them are in Q0 terms. So this will become Q0 dot AB plus Q0 BA plus epsilon. We will rearrange it to make it in terms of R is equal to Q plus RP. Finally, by applying Arden's theorem, we will get Q0 as AB plus BA star, Q1 as AB plus BA star dot A, and Q2 as AB plus BA star B. So these are our two regular expressions that we will have to first combine and then give it as our final answer. So our final R will be equal to R1 plus R2. Now since there are two final states, so we will be having a OR operator being attached here between the two regular expressions of R1 and R2, which we found for Q1 and Q2 respectively. So finally our R will be equal to AB plus BA star dot A plus AB plus BA star dot B. In this we will always not need to solve all the equations that we will be finding. We just need to remember that we have to get only the final states which are present in our transition diagram in terms of only input alphabets. Okay. So even if we get some equations which are so large and huge, do not worry about that unless and until you actually need to solve them to get our final state equations in terms of input alphabets. So that's all for our today's session. In case you have any doubts or queries, you can just leave it in comment section and we can get it resolved in our next session. So see you then.